What is up, everybody? It is Wednesday. It is 4 o'clock, everybody. It is, and that means it's time for streaming on streaming. Welcome back. I am Todd Sharp. I'm your host for Streaming on Streaming. I'm glad you're with me today. If you were with us last week, Aaron, thank you for that reminder. If you could just give me a shout out to let me know that you can hear me okay, that would be very much appreciated. And that way we could avoid wasting 5 minutes of the stream trying to figure out what's up with the audio. Excellent. Thank you, Raymond. Aaron, appreciate it. Glad to see you. Hello from St. Louis, James Keister. Thank you for joining us, and thank you everyone for joining us. I'm really excited about this week's episode, Streaming on Streaming. What is Streaming on Streaming? It is a live weekly show on right here on the AWS Twitch channel, if you haven't figured that out yet. We're developer focused. I am the lead developer advocate for Amazon Interactive Video Service, which is a service in an AWS service that you can use to create live streaming applications just like Twitch. So it's a developer focused show. There'll be no marketing ever. Ground rule number one, keep it friendly. No spam, no abusive, no offensive, any of that kind of garbage in the chat, and have fun. We're here to have fun, and it's going to be an excellent episode today. I have a very special guest this week. Actually, I don't have a very special guest this week. My guest is my keyboard this week. My keyboard, myself, and the 40 or so of you that are joining me right now. We're going to hang out. We are going to write some code. We're going to talk about IVS, get started with IVS. Usually we have guests on. Some weeks we just actually open up the editor and start writing some code. And that's what we're going to do today. So I want to focus today on actually getting started with Amazon IVS. We're going to actually get in the console, open up the CLI, and actually start creating channels and actually broadcasting to them. So let's talk about channels. What are channels? Well, if you think about a site like Twitch, any kind of user-generated content site that has users who sign up and want to broadcast to an audience, just as I'm doing right now, every user that signs up for that channel is going to have a channel associated with it. So a channel is an entity, if you will, where a single creator can broadcast to multiple users. So it's a one-to-many type relationship, right? A channel has one creator and many viewers. And now that's not to say that multiple people can't broadcast to the same channel. As you see here on the AWS Twitch channel, we do have multiple broadcasters who do broadcast to this single channel. The way we do that is via shared stream keys. And we'll get into stream keys in a little bit and kind of explain what they are, how they're used if you're not familiar with them. So a channel can be used by multiple broadcasters, but it can only be used by a single broadcaster at a time, right? So if you have multiple people trying to broadcast to that same channel, the subsequent person who tries to broadcast to that channel will receive an error and they will not be able to broadcast. So if you're going to create some kind of user-generated content platform, you want to build the next Twitch. You want to build a Twitch for bicyclists, or you want to build a Twitch for gamers. Wait, there already is one. Whatever you want to build a Twitch for, whatever you want to build a video user-generated content video sharing platform for, you come in and you can use either the console. You probably wouldn't be using the console if you're kind of on a large scale building something with users who sign up. But you would have to have channels created for every user, right? So you could do that via the console. You can do that via the CLI. You can do that via one of the many SDKs that we have for AWS. And we're going to look at kind of all of those different methods today, just to kind of show you, get you familiar with it, and let you learn how to do these types of things with IVS. Let's talk a little bit about channels, kind of things, topics related to channels, right? Channels can be auto-recorded to S3, which is a really nice feature. If you're familiar with Twitch at all and you've ever broadcasted from to a Twitch channel, you know that a lot of times you can configure your past streams to be recorded, right? So with an IVS channel, you could certainly configure it to record to an S3 bucket. When you do that, you have to have a recording configuration object. And we'll look at that in the console. We'll look at that. I don't think we're going to look at that through the CLI or the SDKs today, but it certainly will point you in the right direction if you're interested in learning more. So your recording configuration, part of that is a setting for generating thumbnails. So if you wanted to generate thumbnails every 5 to 60 seconds, you could do that. So it's just part of your recording configuration. It's just a nice kind of feature to have with your recordings. You know, have a thumbnail that's kind of a single frame from that video every 60 seconds. The other nice things about auto record to S3 is you can actually configure it to merge your recordings if there is an accidental disconnection, right? So if I was streaming right now and my network went out for some reason, or I hit the wrong button on OBS or Streamlabs and I crashed it, if I reconnect within a certain window of time, and the window of time that you have is 1 to 300 seconds, so 1 second to 5 minutes, you can actually merge those recordings. So nice thing to have. You know, if you have a 1 hour show like this, you don't want to end up with bits and pieces of a show if you were accidentally disconnected. When you set up this recording configuration, you get a series of JSON files recorded to your S3 bucket, and those JSON files contain a collection of stream events. So the time that the stream started, you have timestamps, you have a list of all the various artifacts that are produced, playlists that are produced, and all of your streams are recorded, persisted in HLS format, so the same format that is used to stream to your channels as you're streaming live. Playback, if you want to play back these streams, it does currently require CloudFront because the S3 buckets that it records to are all private. So you'd have to put a CloudFront distribution in front of that S3 bucket, set up an origin access identity to access that private bucket, but not a big deal, not difficult to do. And I definitely want to go a little deeper on auto recording to S3 in a future episode, but I don't want to focus too much on that. I just wanted to introduce the concept, let you know that it's possible to do and something that is available with channels. So Aaron says, Todd has effectively hijacked the AWS Twitch channel until he's done. That is very true, Aaron. I have full control, and with great power comes great responsibility, so I will be responsible with that power. So back to channels. Channels can be private or public, right? So by default, your channel is going to be public, meaning there is no authorization, authentication that needs to be done when you are broadcasting to that channel. So if you wanted to create a private channel for whatever reason, you have users that are signed up to your site and you want to make sure that only those authorized users are viewing that stream when they come to your page, you can do that. You can actually set up private and public channels. Now, private channels use a private public key pair for playback authorization. And again, we'll dig into that a little bit more in a future episode. What else about channels? Channels broadcast events to EventBridge, which is also kind of nice. I've played around a little bit with this, but if you think about, some of you may have came here from a notification to your mobile device or your browser. And actually, it's a good kind of time to mention the fact that if you are interested in these sort of things, if you scroll down a little bit, there should be, I'm scrolling on my page to try to find it, there should be somewhere on the page a place to set a notification. If you do want to be notified of future episodes of Streaming on Streaming, you could click that and make sure that you get notified. But back to EventBridge. So that's how basically you could implement something like a push notification to your users who are subscribed to a channel, for example. Maybe you want to send a tweet out. Maybe you want to send a message to a Slack channel. I have a Lambda function set up that sends a notification to a private Slack channel every time my stream starts and ends. So that nice way to notify your users. If you're using IVS for something business related and you have a team Slack channel and you want to make sure everyone knows every time you're live, you could use the EventBridge integration to do that. Checking out the chat here, follow the channel and click the bell to get notifications when we go live. Exactly. And as Aaron tweeted out earlier, actually, the AWS Twitch channel, I believe now has 88.8 thousand subscribers. So that's pretty amazing, pretty impressive. Thank you all for coming and watching. It really helps us content creators and us broadcasters when we have engaging audiences. I should have also mentioned, if you do have any questions, please use the chat. We'd love to hear from you. Tell us where you're from. If you have any questions, let me know. So EventBridge, we're going to look at that again, probably in a future episode. And what else? Channels can be monitored with CloudWatch. So if you wanted to monitor the health of a channel, if you want to monitor the health of a channel, you could do that with the integration with CloudWatch. Foobstiru redeemed Tell Me a Joke. I don't have any good jokes. I'm going to have to stock up on jokes for a future episode, but I am very much welcome to hearing a joke from one of the other people in chat. So if you have a joke that you'd like to share with the stream, please post it in chat. Keep it clean, obviously. We don't want to offend anybody or get in trouble here, but tell a joke. Yeah. So channels, that's channels. That's kind of the overview of channels. It's basically this entity that you create, that you use, as I'm using right now, this AWS Twitch channel to broadcast to a series of viewers. Let's get in and actually start creating a channel. So I've got my browser opened here, and this is the IVS console in the AWS console. So if you go to console.aws.com, come up here to the search box and search for interactive video service. You could click on that and you'll be taken to the main page for the IVS service. So Aaron says, actually, before we get into that, Aaron says, what do you call a fish with no eyes? And the answer is a FSH, a fish. Isn't that a shell? Isn't there a shell called FSH? I believe there is. I don't know. Not sure. Good one, Aaron. Appreciate that. Thank you for contributing that joke to the chat. And anyone else, please feel free to share your jokes as well. So, AWS console, the IVS console. Here we are. The first time you come to this page, you will be presented with this page where you need to actually select a region, right? So the choices that you have to choose a region are shown to you here. I will choose US East because, and if y'all can't see my stream, it looks like the font is pretty good. If y'all can't see my browser too well, please do let me know. But I'm looking at my playback and it looks like the font is pretty good. So as soon as we select a region, we're on the main page of the IVS console here, and up in the top right corner, you see getting started, create a channel, estimated 1 to 2 minutes. Also in the left-hand side over here, you have your overview, you have your list of channels, you have your live channels. So if your channels, any of your channels are broadcasting, you can click this live channels. We'll look at that in just a minute, and it will show you all of the channels that are currently broadcasting in your account. Playback keys and recording configurations are also shown here. The playback keys are what you use for your private channels. You can manage those directly in the console here. If we come down here to chat, we're not going to get into chat today. I have been blogging quite extensively about IVS chat on dev.to/AWS. Guy Jordan, welcome. Nice to have you here. Thanks for joining. So IVS chat, dev.to/AWS. I have been blogging quite a lot over there, and a lot of posts recently on IVS chat. We're not going to look at it today here. We're not going to get into any of that. We'll get into that in a future stream, but this is where you would see an overview and all of your different rooms that you've created for IVS chat. Have some links down at the bottom left in the menu for documentation for the player SDK and the broadcast SDK. So let's click on channels. And when we click on that, we get a list of all of our channels that we have created in this account. We can filter that list. It'll be paginated if we have more than 25, I think, entries in the list. But for now, I have 4 channels created in this account, and we're going to create a new one. So if we click on create channel, and if I bump that font up a little bit more, we get this form here that we can use to create a channel. So if we want to do that, we will say demo console channel 1. And now we have a couple questions. For the most part, it's really straightforward stuff though. You can choose the default configuration, which gives you a standard channel, ultra low latency, and playback authorization disabled. This is the default configuration. We're talking just a second here about what standard and basic channels are, what the difference is between those. If we click on custom configuration, we can change those things. So let's look at what the difference between standard and basic channels are. So if we click on the info link here, over here on the sidebar, we see, and I'm looking, my face is blocking that a little bit, but I think you should be able to see that. So a standard channel includes transcoding at multiple renditions, 1080, 720, 480. And it also allows you to broadcast and deliver live video up to full HD 1080p. Transcoding allows higher playback quality across a range of download speeds. What's the difference between standard and basic? Basic does not include transcoding. It allows you to broadcast and deliver live video up to 1080p. So the way I think of it is this, and I'm going to run this little analogy by you all. In fact, let me switch back to video here while we discuss this. So let's talk about the difference between standard and basic channels, transcoding versus transmuxing. We touched on this a little bit a few weeks ago, but I want to dig into it a little bit and kind of try to break it down and let me know if this makes any sense to you. This is kind of a little demo analogy that I've had in my mind for a while now. So if you think about this red pipe, think of this as your video input. And IVS, for the most part, if you're using something like Streamlabs or OBS or any of the other desktop broadcasting software, for the most part, using those desktop software programs, your video is going to be ingested, sent to our data centers as RTMP, real-time messaging protocol. So let's think of this red pipe as an RTMP input, your video from your house to the data center, right? So your video is this size. This is I believe, 3/4 inch pipe. We'll call this your RTMP input. Let's say it's 1080p. If this was a basic channel, in other words, using transmuxing, not transcoding, if this were a basic channel, you would have this shape, this feed into our data center. And in our data center, if we connect these up, the output from our data center to the player is going to be converted to HLS. So you have RTMP in, you have HLS out, but if you notice, the shape hasn't changed. The only thing that changed is the color here, red to white. RTMP to HLS, right? So transmuxing doesn't change the shape of your video. The only thing it changes is the protocol, RTMP to HLS. Now, there is a little variation on this. Let's talk about the slight variation of that. The only other variation is if you're using our web broadcast SDK, and we'll look at that today if we have enough time. The web broadcast SDK, your input is WebRTC, so this blue pipe. When using the web broadcast SDK, you have our WebRTC in, goes to our data center, gets converted to RTMP, and then again, HLS out. So again, the shape has not changed here at all. We have the same 1080 in all the way through to the end user. So a basic channel is the same resolution from input to output. You don't get any transcoding at all. Now, this is kind of a mess, but if we think about transcoding, we do have that same RTMP in, the same 3/4 inch pipe, but when we get to our data center, what we get is different sizes out, right? So not only do we change the format, red being RTMP, white being HLS, but this time we get different sizes out. We have a 1080 out, we have a 720 out, we have a 480 out, we have a 360 out. So depending on the bandwidth of the end user, the IVS Player SDK will intelligently choose the proper feed to deliver the best quality possible to the viewer of your video. So that's the nice thing about transcoding. If you think about Twitch, for example, as we talked about, or as is, you could Google this and find this out. The only Twitch streams that are transcoded are the Twitch partner streams. And that's because it's a little more expensive. It takes a little more work to produce those very different outputs. So you have 4 outputs from a single input. Everyone else in Twitch is transmuxed. You get that same input, same output. So that's my analogy. Skate Chater. Transmuxing is forcing the same quality. Transcoding is support more sizes, but it happens at AWS. I think that's right. It's not exactly forcing the same quality, it's just leaving the quality, right? So if you have 1080 in, if you're ingesting 1080 with a transmuxed stream, you're delivering 1080 out. So if you have an end user that's on a really poor connection, they're not going to have a really great experience, right? They may experience some latency, some buffering, things like that. The only thing it's doing is changing the protocol used to deliver the stream in a transmux stream. Transcoding changes the shape of the video. It makes it available in different formats so that if the network is poor, they can switch to a 480 stream, for example. And you've probably seen this at some point. I've seen it on other video on demand websites where I'm at a coffee shop, for example, and the network is getting kind of congested, getting kind of crowded, and all of a sudden it switches to a lower quality. And the reason it does that is because it still wants to deliver me the video. It doesn't want to buffer it, but it has to switch to a lower quality in order to continue delivering that feed. Make sense? Awesome. And thank you, Aaron, for posting that link. There's a good article. There's also a part 2. I think it's linked from that blog post that you linked there, Aaron, that goes into a little more detail on that. But it's a tricky concept. It's a tricky kind of topic, and I hope that my analogy didn't confuse the topic too much. It's hard to wrap your head around, but at the end of the day, once you kind of get comfortable with it, it makes sense. Essentially, standard does cost a little more. If you look at our pricing calculator, it will cost you a little more if you want to have a standard channel, but you will also be able to have a better experience for your end user. So it all depends on your business needs. It depends on your requirements, all of these sorts of things. So right now, we're going to leave it as standard. Video latency. You can choose from ultra low latency or standard latency. And the difference here is that low latency reduces the delay between the time from when a camera captures a stream to when the time the stream appears on a viewer screen, what they call the glass to glass time. So the glass of my lens to the glass of your monitor. Ultra low latency can deliver latency in under 5 seconds and is ideal for building interactive experiences. So if you want to, like I'm doing right now, interact with chat, if you're doing some kind of sports broadcast and you want your viewers to be able to interact with each other, then you want ultra low latency. Standard latency is going to be a little longer, but it could improve reliability in certain regions. We're going to leave it as ultra low. We will leave token authorization disabled. If we wanted to create a private channel, as we talked about earlier, we would enable that. This is where we can specify whether or not we want to record and store streams. And if we select auto record to S3, just to show you here, you can actually associate it with a recording configuration, which is just the amount of time that you want to sample thumbnails, the window in which it will merge streams, and the bucket that streams are saved in. So all of that information, you can share that among multiple channels by reusing that configuration. But we'll leave it disabled. And the only other thing to do here is specify tags, and we will not do that. So if I click create, I get directed to the channel details page. Let's take a look at the channel details page. So if we scroll down, we just get a summary of our general configuration. We have the channel type, the video latency, auto record, and playback authorization summary. We also have our ARN. And if we're going to be doing any kind of work with the SDK to modify this channel, to retrieve this channel with the SDK, things like that, we can use this ARN to refer to that channel. We have a live stream here. If we click and expand this, we see a video player that we can use directly here in the console to view our current live stream. Timed metadata. We've talked about this a little bit in the past, but timed metadata is essentially a way to put a tag of data on a specific point in time in a stream. So if I wanted to do the classic example that we always talk about is a trivia app, right? Where the host is hosting and he asks a question. The question is published as timed metadata at that point in time on the stream. On the viewer side, you can render a little window that shows the trivia question, shows all the options, and allows your viewers to vote. Obviously, tons of other uses for timed metadata. Sporting events, for example, you could publish a specific fantasy stat at a certain point in time. You could use it for live shopping. We have a live shopping demo that I've been working on and if you want to see an example of live shopping in action, go to amazon.com/live. And it's just a nice way to be able to, for example, feature a specific product that a influencer or host is talking about. If I'm talking about this lovely pair of IVS socks, for example, I could create an experience where I click a button and a timed metadata event gets published at that point in time, and I can put those socks on sale for the next 10 minutes, for example. Timed metadata is how we would do that. So if we have timed metadata being published, and we'll try to do this actually. We'll try to do this in just a second here. You'll be able to monitor your events right here in the console. Your stream configuration. So this is the important stuff. This is when you want to start broadcasting to a channel, which we're going to do in just a second here. this is the information you're going to need to know. So your stream key. I'm not going to click show because someone out there will be fast enough. How much for the socks, Castech asks. That is a great question, Castech. There may be a trivia question at the end of this stream, and the lucky viewer who gets that right might be able to win those socks. So we'll see how that goes. Stay tuned for sure. And while you're at it, go tell your family and friends to come join the stream as well. I'm sure they all want to learn about live streaming, creating live streaming applications. Or not. So stream key. Stream key is going to be used by your broadcasting software to identify your stream. So when you go to stream to this channel, you would need the ingest server, which is this value here, and you would need your stream key. In fact, let's open up OBS right now and hope that we could do this. Hope I'm not going to destroy my machine with all of the various things that I'm doing here. So let us turn on a FaceTime camera, and this is my camera over here. So you're getting a little behind the scenes peek of me right here. So let's go to settings in OBS and let's go to stream. We'll copy our ingest server. We'll paste that in there. It's actually the same value. And we will also copy our stream key and we will paste that in here. So if we click OK, we now have configured OBS to be ready to broadcast to our stream. We could do that right now by clicking Start Streaming. So at this point, we're 32 minutes in. I've spent 29 of it rambling on incoherently, but we are finally broadcasting to an IVS channel. For the very first time right here on Streaming, we are now broadcasting. So if we come over here and click Live Channels, we can see a list of our live channels in our account. So this demo console channel 1 that we just created is healthy and live. And if we click on it, we get directed back to the channel details. We get directed back to the channel details. Let me mute that so we don't get any echo. But we can see my live channel right here, live and in living color, right in the console. So if I come back to OBS, we'll go ahead and stop that for now. And back to the console, other ingest options here. I mentioned briefly earlier the web broadcast SDK, the blue pipe. If we want to use the web broadcast SDK, this ingest endpoint here is what we're going to need to do that. And we'll come back to that. Excuse me. We will come back to that in just a second. Skate Chater, how would you embed the stream from IVS into, for example, a React single page application? There is a player SDK. There are all kinds of various things that you can do to do that. And we're not going to look at those today, but we will definitely look at those very soon. In fact, next week's episode, we're going to start looking at the player SDK. We're going to have an engineer on from the player team, and he's going to talk to us a little bit about the player SDK, and then we're going to actually get in and start coding that as well. If you do want to read about that, you can check out dev.to. Let me find you a link real quick here. Creating your first live stream playback experience. So here's a link for you for today to get started. It's basically just vanilla JavaScript HTML, but it'll at least get you started, and I'm sure you'll be able to kind of take it from there and inject it into a React app if necessary. So playback configuration. So playback URL, as we were just talking about playback, we can use this URL along with the player SDK to start playing back our video stream. So if I copy that, we're going to need to, so if we want to test this out, we can go to debug.ivsdemos.com. We can paste in our playback URL and come over here and toggle a player. So this will use the IVS Player SDK. You can also use Video.js. You can use the JW Player, HLS.js. We'll just leave the IVS Player for now. Right now, what it's playing is a test stream. This is not my stream, but as soon as I click load, it will try to load my stream. If we click it now, unfortunately, it's not going to play anything because I'm not broadcasting at this point. So this is a nice way to test your playback. If you don't want to use the IVS console, debug.ivsdemos.com to test out our web broadcast SDK, which is a really nice way to create broadcasting experiences for your IVS channel. You can come to stream.ivs.rocks. And if we click on this settings gear down at the bottom, we can use the web broadcast SDK to start streaming to our channel as well. So if I come back to the console, I copy my stream key and I paste it in over here and save, I can now start streaming. And now I'm broadcasting directly from my web browser. I'm not using any third-party software. I'm not using OBS. I'm not using Streamlabs. I'm using a browser. This has a canvas tag to show me the preview on my side of things, but it is broadcasting my stream as WebRTC, which gets converted to RTMP and then delivered as HLS, the white pipe, right? So let's come back over to the debug player. Let's click load. And as you can see, my web broadcast is being broadcast right now. Our latency is about 1.7 seconds, which is pretty darn impressive if you ask me, seeing as how I'm broadcasting to Twitch on the same machine using Streamlabs. I've got IDEs open, I've got terminals opening, I've got everything going on right now, but I'm still getting 1.74 seconds latency. My buffer is 1.5 seconds, and the quality is 1080p. It's being delivered as 1080p. So let's come back over here. If we wanted to, we could also specify, if we have a basic channel, we could specify that channel type here. We can also, if I actually stop streaming, we can also change our stream resolution. So if for some reason I wanted to broadcast in 720 or 480, we could do that. So if I click 720 and start streaming and come back over here and load. So now I'm broadcasting at, it says 360, but now we've gone up to 720. So as I said earlier, the IVS player is intelligent. It uses the best stream in a transcoded channel, a standard channel, based on network conditions. So at the time I loaded that stream, it was at 360, and then it goes up to the maximum 720. In this case, is what I'm broadcasting at. Chigini, I hope I'm pronouncing that right. Chigini, does it automatically save the stream? So you can configure that. We talked about that a little earlier. I'm not sure, you might not have been around at that time, but you can configure it to save your streams to an S3 bucket. We're going to look at that in a future episode. In fact, actually, I have that tab open right here in my browser. So if you want to read a little bit more about that, you could check out the docs for record to S3. So let's come back over here. Let's stop the stream. And our player over here has stopped, which is good. That's what we want. Reload that to clear it out. And that is how you create a channel in the AWS IVS console. And how you get started streaming to it. So Refactor asks, what is the decision point for upgrading quality for users? So that's a good question. It's going to depend on your needs, on your budget, on your requirements. But to make that, let's actually go in and look at. If we go to ivs.rocks, we have a cost estimator. So maybe this will kind of clear things up and let you see the cost. And this is just a calculator. It's an estimator. This isn't guaranteed, right? But if we plug in some numbers here, we can kind of look at the difference in quality and pricing based on the different quality types, right? So for a standard channel, full 1080 in output quality, 2 hours streamed, let's change that to 1 hour streamed, and we have 50 viewers, right? Your video input costs are going to be $2 an hour times 1 hour. And your output cost, and this is based on 50% delivered. It's, again, just an estimate. You can change that down here as well. Let's say 100% of the stream, you have 50 viewers. They all tune in the second your stream starts. They all watch it till the very end. So if you have 1 hour streamed, 1080p on a standard channel, that's going to cost you $9.50. If we switch that to basic, you can see that the cost goes down to $7.70. So the input charge is really the difference here, right? You've gone from $2 an hour to 20 cents an hour. So the more you stream, let's say 6 hours, the more you stream, the bigger the difference this is going to make, right? So $46 for 6 hours streamed at 50 viewers on a basic channel. Standard goes up to 57. So it's a baseline. It's an estimate. Obviously, I can't make any guarantees about pricing or anything like that as a developer advocate. If, as you saw on the main page, where is it? Let's go to, I just want to open this up to kind of make sure that I'm saying the proper thing, so to speak. Where is it? Pricing. Okay. If you plan to use high volumes and are willing to make certain minimum commits, discounted pricing is available. Contact us. So yeah, I just wanted to make sure that I was saying that the right way. Obviously, our cost estimator is just an estimate. If you're going to be creating the next Twitch, you're going to be ingesting tons and tons of video and outputting tons and tons of video. Talk to our sales reps. They'll get you a deal, or discounted pricing is available. Unless you're doing a ton, the difference is not a big deal. And if you are doing a ton, you should be making the money to make up the difference. Yeah, I guess you could say that, right? I mean, so with volume, you're making up the difference. You can also get a discount. Yeah, I mean, essentially, Twitch partners get transcoded streams, right? If we're going to make the analogy to Twitch, Twitch partners get the transcoded streams. Twitch partners bring in the viewers, bring the advertising revenue to the platform, right? So these are the viewers that are making you money, and that money is what you use to pay for the transcoded streams to give them the high quality. All right, 443. We've gotten through about 10% of what I wanted to get through. So let's do a speed run and move on to the next topic. And honestly, the next topic is not really terribly humongous or a huge deal, but I wanted to kind of walk through some other ways to create a channel with IVS, right? So you could create a channel with the console, but that's probably not going to be something that you do on a large scale. So another way to do that is to use the CLI. I do this a lot if I'm spinning up a lot of channels just for demo purposes. And to do that, we use AWS IVS create channel, give it a name, tell it the latency mode, tell it the type of channel that you want. So if we wanted, for example, let me check my notes to make sure I'm saying this right. Yeah, so low is the latency mode, type is standard. If we wanted to authorized or not authorized, no authorized. Okay. So this is a non-private channel, a public channel using low latency and of type standard, in other words, transcoded. So if we do that, We get back a JSON object, and it contains all of that information that we saw in the console. The playback URL, the ingest endpoint, the ARN, the stream key, and there's my stream key. I'm going to immediately come over here and delete this channel so that none of you can broadcast to it. So yeah, that's how you create a channel with the CLI. Let's jump into the IDE and let's look at how to use the JavaScript SDK to create a channel, right? Because you're creating an application. This is what you're going to be using, right? You're not going to use the console. You're not going to use the CLI. You're going to automate this when your users sign up to your channel or your site, your platform. You're going to automate the creation of a channel, right? So let's actually do that. And to do that, we're going to import the IVS client from the SDK. We're going to create an instance of that client. We're going to create an input object, which contains the different values that we want to use. So our channel name, the latency mode, and we'll use low. The type, which is standard. And that's all we use for now. Create a command, which is a new create channel command, passing it the input. We'll send the command. We'll say constant response equals await. We use async await, so we don't have to wait, or so we don't have to deal with promises. And we'll log the response. Log response. So if we run that, and look at the output, should be pretty identical to the CLI output, right? So we have a channel, we have our HTTP response data up here in metadata. We have a channel, our ARN, playback URL, ingest endpoint, same output that we got from the CLI, right? We have our stream key that I'm going to immediately delete. Not that I don't trust you all. You're all lovely people. I appreciate you all very much. I just don't want to get in trouble if somebody started broadcasting to my channel in my work AWS account. So that's deleted. But that's how we create it with the AWS SDK, right? I mean, very simple, very straightforward. If we check the docs over here, link to the docs being posted to chat. This is the docs for the IVS client for the AWS SDK. So create channel command, basically the same thing we just looked at right there, right? You have a client, you have a command that has a shape, and you have a response, which is another shape. We can quickly here do basically the same thing in TypeScript. And the nice thing about that is that we get all of the nice things that we get with TypeScript, right? Like the nice code completion in our browser. Actually, this needs an empty object. So if we create an input, we have a input, create channel command input equals, and here is where we get our nice auto completion, our nice IntelliSense in our browser, right? So we can see the shape of the create channel command input object, and we can do the same thing essentially that we just did with the JavaScript version. Latency mode, we have some static constant values for that, so we don't have to use strings, which is nice, right? Channel type dot standard channel type. So yeah, just a nicer way to do it. If you're using TypeScript, you can do it this way. create channel command equals new. And then our output, our response, we can type that as a create channel command output. I did get a little tripped up doing this earlier when I was playing around with this, and you will get tripped up if you don't use, oh wait, what do we got an error here? No properties in common. Oh, that's why I've done that. Wait a minute. What have I done? Oh, you know what? That's not the input, that's the command. There we go. Oh. Okay. So just a heads up, if you forget the await, it's not going to work, right? Because it's expecting because I've typed it as a create channel command output, and send does not return an output, it returns a promise. So if we await, now everything works, right? If we log our response and we save that and we compile that and we move to the dist directory. Oh, hang on. 9 minutes. Okay. So if we look at the create channel command in the dist directory, we can see this is the compiled version. This is our TypeScript command output. So if we run that, you'll have to trust me, we'll get the same output that we got, well, very similar output that we got from the JavaScript version. Quickly, let's look at a Python version, and I'll just show you the solution. We can import the Boto 3 client, import JSON, create an instance of the client, which is done like this, and then use the create channel method and pass it very similar. I mean, it looks probably almost identical to the JavaScript version, essentially. We're passing all of our various options to the create channel method of the SDK. And that, amazingly, is essentially the basics of creating a channel in IVS. Let me take a look at the chat here and try to catch up. So I'm trying to, Refactor says, let me highlight this. So I'm trying to get things together. We're going to have over 1,000 devices sending data back to us soon and deliver that data into a PWA in the form of a screen recording. Just trying to get an idea of the impact of switching to IVS versus our current solution. Awesome. If you have any specific questions about that, I can say, of course, obviously, screen sharing data, screen recording data, screen sharing is certainly possible. Let's look at that really, really quick. We come back to the web broadcast tool and I click share my screen. I can actually share Chrome tab. Let's see here. Let's share the docs. So if I click share, you can see that it says sharing this tab to stream.ivs.rock. So if I come back here, we get a nice preview of our screen. My video is set up in the bottom right corner here. If we come back to the player tester, actually, we'll come over here to live channels. Did I delete that channel? I may have deleted that channel. It's very possible that I deleted that channel. Let's refresh. All right, channels. Demo console channel. Let's come in there. Copy our stream key. Let's come back to the web broadcast tool. Oh, I never clicked start streaming, did I? There, start streaming. Click start streaming, come back to live channels, refresh, and you can see here, once the quality catches up, there we go. You can see here that I am streaming my desktop via the Web Broadcast SDK. Certainly, if I used OBS or anything like that to broadcast to my IVS channel, I could use all of the features within that tool to do overlays and do all kinds of fun stuff like that. So essentially, anything you need to do sharing your desktop, all the full features of desktop streaming software, all of it's available to you. Anything that you need to do that you could do today with Twitch, you could do tomorrow with IVS. Let's exit out of that. Yeah, we're using Kinesis Video Stream right now, and we're looking at switching to IVS. That'd be great. I mean, we'd love to have as many. We're having to do a bit of wonky stuff and having to stitch it back together on that on our side. Yeah, that's no fun. That does not sound like fun, Refactor. So I'll tell you, if you want to reach out to me, Recursive Codes, look there on the bottom of the screen at Recursive Codes on Twitter. Recursive.codes is my website. Feel free to reach out if I can help you out in any way and assist in that. Be glad to. But yeah, I think it sounds like a perfect solution for what you're looking to do. So with that, we have 4 minutes left, and I did promise a trivia question. So I will have to unfortunately limit this to U.S. residents. So I apologize, but international shipping is super expensive. But for a chance at these lovely, amazing IVS socks, and actually your choice of IVS socks or an IVS t-shirt, let's have the first person who can answer the question, what does this represent? What did I use this to represent in my analogy earlier when we were talking about transcoding and transmuxing? First person, Refactor says HLS close, but unfortunately the white pipe is what represented HLS. PEX piping. That is exactly what it is, Chigini, but unfortunately that's not what I was using it to represent. It is PEX piping, but in my demo earlier, and in fact, if you give me an answer for one of these, whichever one you can remember, if you remember which particular protocol I was talking about when I used the red or blue pipe, you will be the winner. Anybody? Any guesses? If we remember, I looked at, when we were talking about transmuxing, Refactor, it is WebRTC. Castech says you need help with your plumbing. If I could see how you would think that, Castech, because if I've got PEX here, I've got CPVC here, and I've got copper here, you could definitely make a strong case for the fact that I do need help with my plumbing. But the correct answer was WebRTC. So in this demo, in this analogy of transmuxing, this was WebRTC, the red was RTMP, and the white was HLS. So the winner is Refactor, WebRTC. So Refactor, if you'd like to send me your shipping information, and if you would like a t-shirt, let me know your size, and I will ship that out to you. Hopefully you are in the... did Chigini get it right before? Oh! Thank you, Chigini. Thank you, Refactor. I'm sorry, I did not see that response. I appreciate that. And just for that honesty, I will send both of you your choice of socks or t-shirts. So if you want to send me your shipping information, I will be glad to send that. But Refactor said it with more passion, and passion's what it's all about. No, You're both are awesome. I appreciate you all interacting with the stream. It's been very fun. I hope you found it informative. As I said earlier, next week we will be talking about the Player SDK. So if you'd like to tune in and learn more about that, we will be here same time, 4 p.m. Eastern, 1 p.m. Pacific, twitch.tv/AWS. Chigini, Refactor, please send me your shipping information. You can find me on Twitter at Recursive Codes. You can send it to me on LinkedIn. Look for Todd Sharp. Or you can send me a whisper here on Twitch. I'm not sure I have that configured, but please do send me information because I would love to get you a shirt. Thank you all for joining me, and we will see you next time.